Hello and welcome to my channel. In this video, we're going to be looking at recursion in Python. But first of all, what is recursion? Okay, I'll put it this way. A function is considered to be recursive if it calls itself. That is the definition of a recursive function. But what is recursion on its own? So imagine solving a big problem, a complex problem. You don't have a clue on how to solve the problem. One of the approaches of solving the problem is breaking the problem into smaller parts that you can solve. That smallest part or that smaller part that you can solve is considered to be the base case. So what you now do, having broken the problem down, is solving it step by step until you solve the entire problem. So those step by step that you take in the course of solving the problem is considered to be the recursive steps. So in this video, we're going to learn about recursion in Python using 9 practical examples. So we're going to start by learning how we can determine the factorial of a number using recursion. The first example we're going to learn is how we can use recursion to determine the factorial of a number. So what is the factorial of a number? The factorial of any number is the product of all the positive integers of a given number. So if you're asked to find the factorial of 5, this is simply the same thing as 5 times 4 times 3 times 2 times 1. So how do we go about solving this problem? We don't know the factorial of 5, but one thing we know is the factorial of 0 is the same thing as 1. So this is going to serve as our base case. So I'm going to start by defining a function named factorial. So I'm going to have def factorial. And this is going to contain a parameter num. So this is the number that you want to determine the factorial. So the next thing I'm going to do is that I'm going to establish the base case. In this case, I'm going to write if num is equal to 0, then return 1. Then we'll have an else clause where we're going to have else. We can return num multiplied by factorial, and then we'll have num minus 1. So this is going to return it. So this becomes the recursive steps. So this is going to continually call on the factorial function until it gets to this base case where num is equal to 0, and it is going to return 1. So let's call the function and determine whether it can accurately determine the factorial of a number. So I'm going to have result is equal to factorial. And here we're going to have 5. So let me go ahead and print the result. So if I say print result and run the program, it is going to give me 120, which is the factorial of 5. So let's change it to 4. This is going to give us the factorial of 4, which is 24. So the next problem we're going to look at is how we can generate a Fibonacci series using recursion. So first of all, we're going to start by identifying how Fibonacci series looks like. So typically, this is how a Fibonacci series looks like. The first item is 0, the second item is 1, then subsequently it becomes the sum of the two preceding values. So 0 plus 1 is going to give you 1. Then the next value becomes 1 plus 1, which is going to be 2. The next one becomes 1 plus 2, which is equal to 3. So I'm going to start by defining a function that is going to generate Fibonacci series. So here I have def, and for the name we're going to use Fibo. Here we have our parameter as num. Then we'll go ahead and establish the base case. So here we have if num is equal to 0, then return 0. Then we're going to use elif. If num is equal to 1, then it is going to return 0 and 1. So here we're going to have return 0 and 1. Then the next thing we're going to do is that we're going to now determine what happens if num is greater than 1, maybe it is 2, 3, and so on. So here I'm going to be using seq, which is a variable name, is equal to, and I'm going to recursively call on the Fibo function. So here I'm going to have Fibo, and I will decrement the num by 1. So this is going to continually call on the function until it gets to the base case scenario where num is equal to 1, and in that case it's going to return 0 and 1. Then at this point I want to add up the two preceding numbers, so I'm going to be using the append method to append the sum of the two preceding values. So here I'm going to have sequence dot append. So for this I'm going to target the second to the last item, and I'm going to add it up to the last item. So I'm going to have sequence, and then I'll target -1. So this is going to fetch the last item and the second to the last item. The next thing to do is to return the sequence. Then afterwards we can test whether our Fibo function is working as expected. So here I'm going to have result is equal to Fibo, and then I'm going to pass in 5 there. So let's go ahead and print the result. So print result. So this is expected to give us a Fibonacci series, and you can see it will have a Fibonacci series, the first one being 0, 1, 1, 2, 3, and 5. So the next thing we're going to be looking at is how we can generate the sum of natural numbers using recursion. But before we go ahead and start solving the problem, it's important that we understand what a natural number is. If you have 5 natural numbers, you're expected to have something like 1, 2, 3, 4, and 5. So if you are asked to determine the sum of 5 natural numbers, it means you are asked to find the sum of 1, 2, 3, 4, and 5. And we can easily do this using recursion. So here I'm going to have def. For this function I'm going to call it sum net, and this is num, which is the number of terms. Then the next thing we're going to do is to establish the base case scenario, or the base case. The base case is if the number of natural numbers is 0. In that case it's going to return 0. So here I can write if num is less than or equal to 0, then return 0. Then apart from this base case scenario, if the number is greater than 1 and above, well, return 0. So apart from this base case scenario, what happens when the number is above 0? So in that case, we're going to use recursion to continually call on the sum nat until we get to the base case scenario. So here we can have return, I'm going to have num plus sum nat. Here I'm going to decrement the num, so here I have num -1. So this is going to continually keep calling the sum nat until we get to the base case scenario where it returns 0. So let's go ahead and use the function. So here I have result is equal to sum nat. Then I'll provide the num, which stands for the number of natural numbers. So if I put 5 here, I can go ahead and print result, and this is going to give me the sum of 5 natural numbers, which should be 15. If I change this to 100, it's going to give me the sum of 100 natural numbers, which is 1 to 100, and the value is 5050. So the next example we're going to be looking at is how we can use recursion to reverse strings. So imagine that you have a string like this, and you are being asked to reverse the string. So this is what you are expected to get. You are expected to get 0 LLEH. Even though we can achieve the same thing using iteration, we can also do the same using recursion. So how do we go about this using recursion? So let's have a function def. we can call this string reversal. Here we're going to have our parameter, which is going to serve as the string that we want to reverse. So let me give it name. And we're going to start by establishing the base case scenario, or the base case. And for the base case, if the length of the string to be reversed is less than or equal to 1, it should return the string. So we're going to have if len name is less than or equal to 1, then return name. So in this case, if we don't have any string, if it's an empty string, or if it's a string containing one character, it should return that string. Then if this condition is not so, then we're going to use recursion to reverse the string. So we're going to have an else clause here, and for the else clause, we're going to return. Here I'm going to target the last item. So I'm going to be using negative indexing to target the last item. So here I'm going to have name. Here I'm going to put -1. So the next thing I'm going to do is to call on the string reversal function. But this time around, I'm going to be exempting the last character. So here I'm going to have plus string reversal. Here I'm going to have name, and I'm going to do a slicing, and I'm going to be exempting the last character. So I'm going to have here as -1. So let's go ahead and call this function to use it to reverse a string. So here I can have result is equal to string reversal, and we're passing the string that we want to reverse. So I'm going to have hello here, and I'll go ahead and print the result. So this is going to reverse the string. So as you can see, it has reversed the string. Then another interesting example we're going to look at is power of exponentiation. So this is power of exponentiation. So imagine that you are being asked to determine the value of 2 raised to power 3. This should be 2 times 2 times 2. And if you have 2 raised to power 4, it is the same thing as 2 times 2 times 2 times 2. So it may be very overwhelming for you to determine 2 raised to power 4. But one thing we know is any number raised to power of 0 is going to give you 1. So that will become our base. So what we're going to do is that we're going to write a function that is going to determine the power of exponentiation using recursion. So here I'm going to have def power. Here I'm going to provide the base, and I'm going to provide the exponentiation. Then the first thing I'm going to do is to establish the base case scenario. In this case, I'm going to have if ESP, which is exponentiation, is equal to 0, then it should return 1. So I'm going to have return 1. Then else, I'm going to have the base multiplied by, then I'm going to call the function, which is power. This time around, I'm going to pass in the base, but I'm going to decrement exponentiation by 1. So I'm going to have ESP minus 1. So let me go ahead and use return to return this value. So this is how we can recursively call on this function until it gets to the base case scenario where the value is equal to 1. So ultimately, the base keeps multiplying itself until it gets to the base condition where the value to be returned is equal to 1. So let me go ahead and call this function. So here I'm going to have result is equal to power. Here I'm going to be providing my base. So let's have it as 2 and the exponentiation as 5. So let's go ahead and print the result and run the program. So this is going to give me 32. So if we want to do 2 raised to power 2, this is going to give us 2 raised to power 2, which is equal to 4. So now we're going to be looking at the GCD, which stands for the greatest common divisor. So imagine that you have these two numbers. We have 3 and 6. The GCD should be 3 because that is the highest number that can divide the two numbers. And we can use recursion using what we call the Euclid algorithm to determine the GCD of numbers using recursion. So here I'm going to have DEF. We can call this function GCD. Here I'm going to be providing the two numbers which we want to determine the greatest common divisor. So I'm going to have this one as num1, and here is going to be num2. Then here I'm going to establish the base case, and for the base case we're going to have if num2 is equal to 0, then it should return num1. So here we're going to have return num1, else it is going to return GCD. Here I'm going to have num2, and I'm going to have num1 modulo num2. So let's go ahead and run this program. So here I'm going to have result is equal to GCD. Here I'm going to be providing 3 and 6. So let's go ahead and print the result. And this is going to give us the greatest common divisor, which should be 3. So if I have 15 here, 15 and 6, the GCD should also be 3, which is here. So if I have 15 and 25, the GCD should be 5. So you can see that it is working. Then the next thing we're going to look at is palindrome checker. If you want to determine whether a string is palindrome. So, but first of all, what is palindrome? A palindrome string is a word or a number or sequence of characters that reads the same thing backward as it is forward. So if you have something like level, level is a palindrome string, because if you reverse it, it is still going to give you the same thing. Another palindrome string is something like madam. This is palindrome. If you have 1, 2, 1 like this, it is palindrome. Then if you have something again like 1, 2, 3, 2, 1, this is also palindrome, because if you reverse it, it will still give you the same thing. So we're going to be using recursion to determine if a string is palindrome. So what we're going to do is that we're going to have DEF. Then for this function, we're going to call it is palindrome. Here we're going to have the string that we want to determine whether it is palindrome. So we can call it name. So first we're going to establish the base case, and this is where the number of characters is 1 or empty. If it is 1 character or empty, it should return true. So here we're going to have if len name is less than or equal to 1, return true. So the next thing we're going to do is, if you want to determine whether a string is palindrome, what this means is that the first character must match the last character. The second character must match the second to the last character. So here we're going to have if name, here we're targeting the first one, which has the index of 0, is not equal to, then we're targeting the last one, which is equal to -1, then it should return false. So this is going to be return false. But apart from these two conditions, this is what we want to return. So we're going to return. Here we're going to be calling on the is palindrome function. So we have is palindrome, And what we're going to do now is that we want to target the second to the last and the second, since this one is going to capture the last and the first. So here I'm going to be using slicing to target the second and second to the last. So here I'm going to have name, and I'm going to have one here, then put a colon, and then target the second to the last. So this is going to continue calling itself until it gets to the condition where the length of the string is less than or equal to 1. And if all the conditions turn out true, then it is going to return true. Else, it is going to return false. So let's go ahead and use this function to determine whether some strings are palindrome. So here we're going to have result is equal to is palindrome. And we're going to pass in a string. So let's use level. So let's go ahead and print the result. And for the value, it's going to give us true because it is palindrome. If I put car here, it is going to indicate false because it is not palindrome. But if I change this to madam, it is going to return true. And if I change it to 121, it is also going to return true. So this is how we use recursion to determine whether a string is palindrome. You can also use the same to determine whether a list or any other sequence are palindrome. And we're also going to be looking at how we can generate arithmetic progression using recursion. So, but first of all, an arithmetic progression is a sequence of number where the difference between any two consecutive terms are always the same. So when you have something like 1, 2, 3, 4, 5, this is an arithmetic progression, and the difference between two consecutive terms are 1. Then when you have something like this is also an arithmetic sequence. When you have 1, 3, 5, 7, the difference is 2. Okay, it mustn't start from 1. It can start from maybe 10. And we have 14, which means that the difference is 4. The next term is going to be 18. So this is an arithmetic progression. So one thing about arithmetic progression is that there is always a starting value, which we can call A. Then there is a common difference, which we can call D. And there is also the number of terms, which we can call N. The number of terms is number of numbers there. So let's go ahead and use recursion to determine or to generate an arithmetic progression. So here we're going to have DEF. We can call this function AP. So here we're going to have A where we want it to start. Then we'll have a common difference, and then we'll have the number of terms that we want to generate. Then the next thing we're going to do is to determine the base case, and this should be a scenario whereby the number of terms is equal to 0. In that case, it should return an empty list. So we can have if n is less than or equal to 0, then return an empty list. So now we're going to recursively call on the AP function, but first we need to get the first term. So here we can have return. Here I'm going to have A. Then I'm going to add it to a recursive call to the AP function. So here I'm going to have AP, and this time around, the first term is going to be the sum of the initial first term and the common difference. So here I'm going to have A plus D, and I'm going to also have D as the common difference, and I'm going to decrement n by 1. So here we have n minus 1. So let's go ahead and use this function to generate an arithmetic progression. So we can have result is equal to AP. We want it to start at 1. Then the common difference is going to be 2. And the number of terms is going to be 10. So let's go ahead and print the result. And this is going to generate an arithmetic progression for us. So this is the arithmetic progression. So finally, we're going to use recursion to perform binary search. So, but first of all, what is a binary search? So binary search is an efficient way to find a target value in a sorted list. The algorithm works by repeatedly dividing the search range into half. First, the target value is compared to the middle element of the list. Then if the target is smaller, the search continues in the left half. If it is larger, the search moves to the right half. The process repeats until the target is found or the search range becomes empty. So how do we go about this? So first of all, I'm going to define a function which I'm going to call binary search. So here is going to be def binary search. For the parameters, I'm going to have the array that I want to search, and then we'll have the target, which is the value that I want to search. Then this is the low and this is the high. So I'm going to start by comparing the low and the high. If low is greater than high, it should return -1. So here I'm going to have if low is greater than high, then return -1. Then for the mid, I'm going to have the sum of the low and the high. Here I'm going to perform an integer division, dividing it by 2. So if the element in the middle is equal to the target, it should return the index. So here I'm going to have if array, and then I'll put mid is equal to target. Then it should return that index. So here we have return mid. And if not, so have elif. And for this, we're going to have array at the middle. So we'll have at the middle is greater than target. So what this is going to do is that if the item at the middle is greater than the target, it means that the search should be targeted towards the left. So we're going to establish a new high. So for this, we're going to recursively call on the function. We're going to have return. Here we'll have binary search. And for this, we're going to have our array. We'll still have our target. We'll still have our low. But this time around, we're going to subtract 1 from the mid. And finally, we're going to have an else clause. And for the else clause, we're going to return binary search. That is a situation whereby the value is less than the target. That means it should search the right side of the sequence. So here we're going to have array, we have our target. Here we're going to have mid plus 1, which becomes our new low, and then we'll still maintain our high. So this is how the process is going to continue until a match is found. So let's go ahead and then use this function. So here we have a sorted list. So let's call this norms is equal to, we'll have 1, 2, 3, 4, and 5. Then we establish a target, and for the target, we can call the target to be equal to 4. So now we're going to be calling the function. So we're going to write result is equal to binary search. And for the argument, we're going to pass in the array, which is the norms. And we'll have our target. And we establish the low as the first item in the sequence, which is going to be 0. And then for the last item in the sequence, we're going to target the index of the last item. So here we're going to have len norms minus 1. So this is going to give us the index of the last item in the sequence. So let's go ahead and print the result. So here we have print result, and here is the outcome 3. And this is the index of 4 in the sequence. So if I change this to maybe 1, this is going to return 0, which happens to be the index of 1 in the sequence. So this is how binary search works. So essentially, you can see that recursion is a very powerful tool in programming. In fact, it is one of the most common approaches of solving problems in programming. I encourage you to practice all these examples that are provided in this video. So you can see that recursion is a very powerful problem-solving technique in programming. So I encourage you to use the examples in this video to practice recursion. The more you practice, the better you become at problem solving. Please don't forget to like, subscribe, and share this video. Thank you, and see you next time.